Dear students, in the class we are going to discuss few important points in the analytic function. It is called analytic function. Analytic function is a complex function which is expressed as f of z is w, which is u plus id. When it is satisfies some condition ux equal to vy and uy equal to minus vx. This condition is the necessary condition for the function f of z to be analytic. That condition is called Cauchy-Riemann equation. Now we will see what is called that single valued and the multiple valued. Single value and the multiple valued function. See, for example, single valued function means consider one function for every value of z, a unique value of w is there. This is it, w. For example, w equal to z square. So minus 1, z is minus 1, 1 minus 2, 2 like that. Then in case w equal to z square, when z value is one, 2, minus 2, minus 1 is there, then w is 1, 4, 4, 1. So 1 and 4 is here. So for each and every one value of z, some corresponding value is there in the w. That is called a single valued function. Whereas multiple valued function, multiple valued function means if there is more than one value, there is more than one value of w corresponding to a given value, of z. So then w is called multiple valued function. See, for example, W equal to Z power of. W equal to Z power of means Z value is there 4, 9, 1. For this value, W is minus 2, 2, 3, comma minus 3, 1, comma minus 1, like that. So this type of function is called the multiple valued function. Next one important note, the distance between 2 points Z and Z naught. Okay, Z naught is here, X naught comma Y naught. So value of Z is there, X comma Y. The distance between Z and Z naught is Z minus Z naught. This notation. Generally, Z minus Z naught equal to square root of X minus X naught whole square plus Y minus Y naught whole square. In case we are taking Z square on both sides, you will get that X minus X naught whole square plus Y minus Y naught whole square. We can see that in case if you are writing that Z minus Z naught as some delta, then we can write delta square equal to X minus X naught whole square plus Y minus Y naught whole square, which is the equation of the circle with the radius delta and the center X naught comma Y naught. Next one important note, whatever we told now, that is the circle C of radius delta with the center at the point Z naught can be represented by mod Z minus Z naught equal to delta. So generally mod Z minus Z naught equal to delta means that is the equation of the circle with the center Z naught and with the radius delta. X may be anywhere on that circle. In case mod Z minus Z naught less than delta represents the interior of the circle excluding its circumference. Is it clear? Excluding its circumference. Next point is, in case you are writing that mod z minus z naught less than or equal to delta, means that is it include both interior and circumference point. Represents the interior of the circle including its circumference. In case mod z minus z naught greater than delta represents the exterior of the circle. This point is required for both unit 4 and unit 5. Even these points are useful for that unit 4, the complex variable, and then complex integration also we can use these points. Next note, there is a note number I didn't write that. See, this is note 1, note 2, note 3, note 4, note 5, note 6. What is note 6? A circle of radius 1 with the center at origin can be represented by mod z equal to 1. Next one important definition is the neighborhood of the point. Neighborhood of a point z0. When that point is said to be the neighborhood of the point z0. Okay, we'll draw the diagram. X and Y. And circle is there. Instead of we can draw that some proper circle is there. We will draw. Okay. And there is. Now we can draw that a proper circle here. Through the shades there. Draw the circle. It's looking good. Okay. Now what is the center here? Z0 is the center, and then some point Z is there. Delta is the radius. So what is meant by neighborhood? No need to write every time neighborhood. Just we can write neighborhood NBD of a point Z0 of a point Z naught, we mean a sufficiently small, mean a sufficiently small circular region, circular region. So here you need to note down that excluding the points on the boundary. That means mod z minus z naught less than delta. So anywhere you can take that point, any point which is said to be neighborhood of z naught means that should be including the points on the boundary. See, for example, in case is that sun, solar system. Okay, fine. So the center point is sun. This Saturn is there. For the Saturn, the Earth is here. Earth is the neighborhood of sun. In case we are taking that Pluto or Neptune, okay, so that planet is not the neighborhood of that sun. According to that Saturn. In case we are taking Z, the point Z as a Pluto, then Saturn and the Earth and other things, Mercury, everything is the neighborhood of the sun. Okay. So whatever you consider the neighborhood, that is based on the scale. So here scale is not the matter, whatever the bigger, okay, that is based on this formula, Z minus Z naught less than delta. Fine. Hence delta is the arbitrary small positive. Here delta is the arbitrary small positive. Okay, fine. Next definition, limit of a function. When it is said to be that limit of a function. We will not solve the problem based on this, just we write what is the definition for this. In case that f of z be a single valued function, defined at all points in some neighborhood of point z naught. Then the limit of f of z as z approaches z naught is w naught. That means limit z tends to z naught f of z equal to w naught, because you are taking that w is a f of z. Important note we can write. See, the complex quantities z and w can be represented on separate complex planes. Now you can write that in the separate complex planes. So if you are writing that complex quantity z and w in that separate complex plane, which is respectively called the z plane and the w plane respectively. The relation w equal to f of z establishes correspondence between the points x comma y of the z plane and the points u comma v of the w plane. So we can draw the diagram based on this important note, that is, so here we can draw one coordinate axis, copy and paste it here. Sorry. Select this. We can move from here to here to minimize our space. Okay, now we can write that what is called, this is the z plane, this is the w plane. So here z can be written as x plus iy, w can be written as u plus iv, and then once again I need to move it. Then I need to draw this. On the W plane. Okay. Here for the W plane, W equal to U plus IV. So what is the length here? This W, it is Z and it is W. So here we can write it as x-axis, this y-axis, this axis Q, this axis V, the respective origins also, and as O and O dash. These are the few important notes for this analytic function f of z. We need to know this, what is meant by single valued function, multiple valued function, and then what is called the neighborhood, what is the limit of the function. In the next class, we will discuss few important things based on these limits and the continuity of the function. What is called the continuity of the function. Thank you.